This screencast is about the second time series smoothing method, exponential smoothing. Both moving average and exponential smoothing work best when applied to stationary time series. That is, when applied to time series without significant trend, seasonality, or cyclicality. To accomplish exponential smoothing, we first pick a smoothing constant W between 0 and 1. A W near 0 results in a smooth series that changes slowly from period to period. A W near 1 results in a smooth series that closely tracks the original series. In exponential smoothing, there is a smooth series value for every value in the original series. That is, no series values are lost. Here's the general procedure for creating the exponentially smooth series E1 through En. The first exponentially smooth series value is taken to be the first actual series value. Subsequent exponentially smooth series values follow the same pattern. They're sums. Each puts a weight of W on the corresponding actual series value and a weight of 1 minus W on the previous exponentially smooth series value. So E2 is W times Y2 plus 1 minus W times E1. And as I said, that pattern follows through all the exponentially smooth series values. Here's an Excel worksheet set up to compute the exponentially smoothed values, the exponentially smooth forecasts, the exponentially smooth forecast error, the magnitude of the exponentially smooth forecast error, and the MAD. Note that the worksheet has a designated cell away from the body of the table in which to place the weight factor. We have chosen the cell G2. Subsequent reference to this weight factor will be made with fixed cell references. That is, putting a dollar sign in front of the G and a dollar sign in front of the 2, so that when we drag a formula, the G2 will not change. The first exponentially smooth series value will be taken to be the first actual series value. The second exponentially smooth series value will be the weight times the second actual series value plus 1 minus the weight times the previous exponentially smooth series value. This formula is then pulled down throughout column C. The exponentially smooth forecasts in column D are obtained by moving the exponentially smooth series values in column C ahead one period in time. So, the exponentially smoothed forecast for period 16 is just the exponentially smooth series value obtained for period 15. The exponentially smooth forecast error is computed as with moving averages as the difference between the actual series values and the forecast series values. The magnitude of the exponentially smooth forecast error is computed also as with moving averages using Excel's absolute value function. the MAD is computed again as in moving averages as the average magnitude of the forecast error. We move to the next page. You're asked to compute a U-try problem. Of course, all these U-tries are to be completed using a standard hand calculator, similar to what you might see on an exam. Using a weight factor of 0.5 to complete all of these columns for the weekly unit sales data. When you complete these entries, you can pull down the text box to check your answers. On the next page, we see the simultaneous scatter plots as we saw in the case of moving averages. Note that the exponentially smooth series has no lost values. Again, for the forecast series, we see that the forecast error can be computed as a vertical distance between the actual and forecast values. This first one would be positive, as we would see here. The next one, actual minus forecast, would be negative, as we see here, and so forth. Here's our forecast for the 16th week. That's the value we would obtain here. We've once again moved to the next page. Here is another table completed involving exponential smoothing, except this time the weight factor is 0.25. Here are the exponentially smooth values. Here are the exponentially smooth forecasts. And here is the MAD 13.86 average forecast error magnitude. On the following page, we see again the same simultaneous scatter plots, except now for the exponential smoothing with a weight factor of 0.25. On the next page, we ask the question, which of the four models we've worked with so far, the MA3 model, the MA5 model, the exponential smoothing model with a weight of 0.5, the exponential smoothing model with a weight of 0.25, which of these four models are best to forecast the weekly unit sales values? The answer is the best model is the one with the smallest MAD. That is the exponential smoothing with a weight factor of 0.5 with a MAD of 10.32. This is a good point to complete homework 7 problems 1 and 2. This will complete this screencast.